Alright, welcome. This is the SBAC test review packet solution. This is going to be going over the question page 4 and page 5. Okay? Alright, so we have chapters 4, number 10 here. It says consider the line shown on the graph. Enter the equation of the line in the form y equals mx plus b, where m is the slope. Okay, so the two things that you need is your m, which is the slope, and the green b is the y-intercept. Okay, notice this is a proportional relationship because this is a line. And it starts at 0, 0. Therefore, it is a proportional relationship. Okay, let's figure out the slope. You start at 0, 0, which is the y-intercept. Okay, so you could say the y-intercept is b equals to 0. You go up 4, then across 1. Therefore, the slope is m equals to 4 over 1. Therefore, you plug it into the equation y equals mx plus b. M, which is the slope, is 4 over 1. The b here was 0. So your equation is y equals 4 over 1x plus 0. Number 11. The graph shows a proportional relationship between the distance traveled Eric by time on a hiking trip and the numbers of hours which he traveled. Which statement identify the correct slope and the correct interpretation for the slope of this situation? We start from 0, 0. It went up 4, 5, 6. Then it went across 5. So you could already remove A and B because it is wrong. The slope should be 6 over 5. Then you can just plug in the values and put into its context. It went up 6. What did the 6 represent? Distance, which is miles. So it should be 6 miles. This one says 6 miles, which is the only one. Therefore, you would say the slope is 6 miles. And the bottom one is 5 hours because that is the unit for the x-axis. So C would be your answer because it is 6 miles for every 5 hours. Sometimes you might see the word per in there. So you could say 6 miles per 5 hours. Okay? Number 12. A cherry blossom leaf falls 20 feet from a branch to the ground at a rate of 4 feet every 2 seconds. Determine whether each statement about the leaf, this should be leaf, is true. Select true or false for each statement. The initial height of the tree is leaf tree is 20 feet. Starts from 20 feet. So that is true. 20 feet from a branch. The leaf falls at a rate of 2 over 1 foot every 1 second. Look at it. It says 4 feet every single 2 seconds. So that is 2 feet for every 1 second. So that is false. The leaf is 6 feet above the ground after 6 seconds. Let's see the calculation. 2 seconds would be 4 feet. That's what it says here. So 4 seconds would be 8 feet. 6 seconds would be 12 feet. 20 seconds minus 12 seconds, because that is what it says here. 20 seconds minus 12 seconds, right, will get you 8 seconds at 6 seconds. Sorry, 20 feet minus 12 feet will equal to 8 feet, okay, at 6 seconds, okay? It would be a subtraction here. So you subtract 20 by 12 feet, 20 feet, subtract 12 feet will get you 8 feet at 6 seconds. So this should be really feet, okay? All right? Here, I could change it for you if that makes no sense for you. Feet at 12 seconds. Okay? Here you go. You should be happy now. Right? Good? Okay. Let's look at now chapter 14, which is page 5. Which is number 13. The graph below represents Rachel's speed during her 20-minute jog around her neighborhood. Based on the graph, determine whether each statement is true. Select true or false for each statement. Rachel's speed during the jog is increasing between 3 and 5 minutes. So let's look. That is 3 minutes. That is 5 minutes. Is it increasing? No, it is flat. That's why it's false. Next, her speed is constant between 9 and 11. There is 9, that is 11. Is it constant? Is it flat? Yes, it is, so therefore it's true. Rachel's speed during the jog is decreasing from minute 12 to 14. There is 12, that is 14. Look at that interval, it is going down, so it is decreasing, so that is true. Number 14. The graph of x plus y equals to -9 is shown. Graph the equation y equals 3x plus 1 on the coordinate plane so it intersects with the first equation. The y-intercept for this equation is 1 because it's plus 1 right here. So I put the dot there. The slope here is 3 over 1 because it is the number in front of the x, which is 3. Put it in fraction form, it becomes 3 over 1. So we go up 3, then across 1, then put a second point. If that is too fast, let me repeat. The slope is 3 over 1. Therefore, we go up 3 for the change in y, then across 1, which is your change of x. Put a dot there, connect the lines. Okay, please extend the line both ways so it could intersect. Good? Next, number 15. A biologist tracked the efficiency of a new cancer vaccine. Without applying the vaccine, the number of cancer cells is 1,200 parts per million in the bloodstream. Every dose of the vaccine, the number of cancer cells decreased by 50 parts per million. How many vaccine dosage must be used to reduce the cancer cell to a safe amount of 300 parts per million? Do not be scared about the units here, the parts per million. You might think you have to multiply by a million. No, right? It's like the same thing as like saying 1,200 ounces, right? Or 1,200 meters. It's just a form of unit. Don't be so afraid, okay? All right, so without applying, it is 1,200. That's why it's considered the y-intercept. So b equals to 1,200. Look at the key word here, without applying, or you could also look for the word like starting. Next, it decreases by. Decreasing by, increasing by would indicate a slope. 50 parts per million, so your slope here would be 50 over 1. Right? Plugging into the equation of y equals mx plus b, you get y equals 50 over 1x plus 1,200. Okay? It said to a safe amount of 300 parts per million. That's why the y is 300, because that is the safe amount of 300 parts per million. Subtract 1,200 to both sides, you get 900 equals 50 over 1x. Divide by 50 to both sides, you get x equals to 18. So at 18 doses, you get your 30 parts per million. So make sure you get the y-intercept, get the slope, plug it into the values, then solve for x. But there you go. That is your solution for page 4 and 5.